Listing strategies is what we're going to look at in this video. We're going to start off by looking at listing combinations, to answer 3 questions where we've been asked to list a combination. We're then going to move on to answering questions where we've been asked to find the number of combinations, and then questions where we've been given the number of combinations but being asked to find X, and then move on to looking at questions with OR. So what happens when you have all these different types of combinations that we want to combine, and then moving on to questions around tournaments and teams and matches, and then looking at combinations. So that's normally to do with locks and passcodes, and then finally moving on to looking at rearrangement with cards and so on. And as always, we'll wrap up with looking at a real exam question. So the way my videos work, I'm going to do the example on the left, which is I do. You're then going to press pause and have got the example on the right, which is you do. So this is a question on listing combinations. We've been asked to list all possible combinations that Sam can choose. So we have starters, soup, mushroom, and then we have main, which is fish, beef, and chicken. So he's going to pick one starter, we've been told, and one main. So if he picks one starter, he could pick soup, and he could pick soup with one fish, so one main, or he could pick soup with beef, or he could pick soup with chicken. Instead of soup, he could have chose mushrooms, and again, he could have chose mushroom with fish, or mushroom with beef, or mushroom with chicken, and that is how you answer a question like this. So press pause and have a go at the example on the right. So in this case, he can choose one shirt, one tie. So we have a white with a plain. Let me sort that out, white with a plain, and then we can have a white with a striped, and then we can have a white with a checked, and then we can do the same with the blue. And we can do the same with the grey. Here's some practice questions for you to have a go at. Press pause and have a go. And it's worth noting that in B and C, the outcomes haven't been listed, but with a coin, you obviously have tails and heads. And then here with the dice, you have obviously a dice goes from 1 all the way to 6. Here are the answers, mark your work. And now looking at this one, so we've been asked to now find the number of combinations. So earlier we listed them. So to find the number of combinations, so we have how many starters? We have 2 starters and we have 3 main. And all we need to do is 2 times 3, that gives us 6. That is the number of combinations we have. And if you're wondering where the 6 came from, you can list them out. So we have soup with fish, soup with beef, and soup with chicken. And then we have the same with mushrooms. And you can see in total, there are 3 of these and 3 of these, and that gives us 6 altogether. So again here, all we need to do is multiply them all together. So that's 5 times 2 times 4. 5 times 2 is 10. 10 times 4 is 40. So again, press pause and have a go at these questions. Here are the answers, mark your work. Moving on, we are now looking at finding the value of X. So in this question, we have starters, main, but we don't know how many desserts we have, but we've been told how many different combinations there are. Now we know how to get the number of combinations, we just multiply all of that together. Now we don't know the desserts, so we'll call desserts X is equal to 420. Now to tidy this up, 5 times 12 is 60, so we have 60x is equal to 420. If I now divide each side by 60, I get x is equal to 7. So that's the value of x. Again, hopefully you've pressed pause and had a go at the example on the right. So here, exact same thing, 504. And then you just need to do 12 times 7, which is 84. And then just a case of doing 504, divide that by 84. That gives you 6. Here's some practice questions, press pause. Here are the answers, mark your work. Now moving on, we are looking at number of combinations with all. So in this case, we have a shop that has shirts, ties, and shoes. Sam is going to choose one of the following combinations. So he's either going to pick a shirt and a tie, or a shirt and a shoe, or a shirt, tie, and shoe. And the or is just going to be a plus sign, okay? So what we're saying is he can either pick a shirt and a tie. So there are 9 shirts and there are how many ties? 15 ties. So he can either do this or he can do this, which is a shirt and a shoe. Or he can do this, which is a shirt, a tie, and a shoe. Okay, so now if I calculate these, I get 135. Okay, 72. And then finally, I get 1080 here. Now what I need to do is add this and this and this. Okay, that's all that all means. It just means add them. So if I add 135 plus 72 plus 1080, I end up with So again, hopefully you press pause and had a go at the example on the right. So we have a starter and a main. We have a main and a dessert. And then we have a starter, a main, and a dessert. And now I'm just going to add all of that together. So that's going to be 60 plus 15 plus 180. 255 is the answer there. So again, press pause and have a go. Here are the answers, mark your work. Moving on, we're now looking at the number of matches. So we have 3 teams play a competition. Each team has 2 matches against each other team. Work out the number of matches played. So there is a formula we can use for this. So firstly, I'll show you how it works without the formula. So let's just say we have 3 teams. We have Team A, Team B, and Team C. Now Team A will play Team B, and it will play Team C. And then Team B will play Team A and Team C. And then Team C will play Team B and Team A. So in total, we have Team A, Team B, Team C. How many matches are played altogether? Well, A plays B and C, so that's 2 there, 2 there, 2 there. So in total, we have 6 matches. Now, there's a little formula that we can use to find this, and that formula is n bracket n minus 1. And the reason for the formula is because here we have 3 teams. What if we had 15, right? It'll be quite hard to list them out. So if we use this formula, how many teams are there? 3, bracket 3 minus 1. That then becomes 3, bracket 2. And now what's 3 times 2? That's 6, okay? So hopefully you've pressed pause and had a great example on the right. Now with this, we can list them out, but it's just easy if I just use the formula. So that's 5 times 4, which is 20. Again, you could have listed it out like I did here. So that would be A, B, C, D, E, and then you can list out all the combinations, but this is quicker. Now moving on, this question's slightly different. If I go back to the previous question, it said each team played 2 matches against each other. If I come here, it says each team plays the other team exactly once. Now, what does that mean? So if you go back to what we had A, B, C. So Team A plays Team B, and then it plays Team C, which is fine. Now, Team B has already played Team A here. Okay, Team B and A have already played, and they only played once. So we can't play that same team again. Who has Team B not played? Well, Team B hasn't played C. And who has C not played here? Well, C's played A up here, and C's played B up here, so there's nothing left to go there. So altogether, how many matches are there? Well, there's 1, 2 there, and there's 1 here. So there's 3 matches altogether. Now again, there's a formula for working this out, and that formula is n bracket, let me just tidy that up. It's n bracket n minus 1 divided by 2. Okay, it's the exact same formula, but we half this time, so that becomes 3 bracket 2 over 2, which is 6 over 2, which is 3. Again, hopefully you've pressed pause and had a quick example on the right. Again, we can list it out, but it's a bit long. We can just use the formula. So that's 5 bracket 4 over 2. That's 20 over 2, which is 10. Press pause and have a go. Here are the answers. Mark your work. So now we are looking at combinations. So there is a 3-dial combination lock, and each dial can be set to 1, 2, 3, 4, or 5. Work out the number of 3-digit combinations that can be set. So in this question, we actually have 2 questions. This is a question, and this is a separate question. So in this case, it's saying work out the number of 3-digit combinations. So we know it can have 1, 2, 3 digits, and each digit has 5 options. So we can just do 5, 5, 5. If I multiply together, we get 1, 2, 5. Now for the second part of this question, it's saying each number, work out 3-digit combinations if each number be different. So what we're saying is the first time round we have 5, the second time round we have 3, 4, and the second time round we have 3, because we can't repeat the same number. So this then becomes 5 times 4, which is 20, and times that by 3, which is 60. Okay, so the exact same thing here. We have 4 digits now, so we have 1, 2, 3, 4. We have 7 options each time. So it'll just be 7 times 7 times 7 times 7, which is 2401. Now, in the second case, it's saying that the 4-digit combination, if each digit number is different. So if each digit number is different, we then have this. So that's 7 times 6 times 5 times 4, which becomes 840. So now we have a lock uses a code with 2 letters followed by 2 numbers. So we've got 2 letters followed by 2 numbers. Work out the number of combinations that can be the code. Cool. So we have 1, 2, 3, 4 together. Now, how many letters can we have? We can have 26 letters. Okay, in the alphabet, there's 26 letters. And how many numbers can we have? It just says numbers. So we can have 10 numbers altogether, because numbers go from 0 all the way to 9. And again, we can have 10 here. So the answer here just becomes 26 times 26 times 100, which is 67600. Now for the second one, it's just saying the exact same thing. That can be the code if each digit and letter is different. So we have 26 letters the first time. Since we can't repeat the same letter, we then have 25. And again, we have 10 digits the first time, but because we can't repeat, we then have one less. So we have 26 times 25 times 10 times 9, and that gives you 58500. And again, hopefully you've pressed pause and had a go at the example on the right, so I can see straight away there's 6 of these, there's 3 letters, there's the time sign, and then there are 3 digits. So that's just 26 times 26 times 26 times 1000. So that is something like 0.75760000. And then looking at the next one, it's the exact same thing, but this time we just can't repeat. So if I type that into my calculator, I get 24 times 10 times 9 times 8. That is 1123200. So here's a question for you to have a go at. Press pause and have a go. Here are the answers. Mark your work. And now we are looking at arrangement. So we have 3 cards here, 2, 4, 6. How many ways can they be arranged? That should say they really. So we have 2, 4, and 6. Now I can rearrange this as 2, 6, 4. Or I can start with 4 and do 2, 6. Or I can do 4 and then 6, 2. And the other way I can rearrange this is start with 6, and then we have 2, 4, and then 6 and 4, 2. So there are 6 ways this can be arranged. Now again, there is a little shortcut to doing this, and we use, so how many cards are there? There's 3 cards, and we just write 3 with an exclamation mark. Now that just means 3 factorial, and all that means is we're doing 3 times 2 times 1, and that becomes 6. Okay, that's all the factorial means. If I add the factorial to any number, like 5, it just means I'm going to do 5 times 4 times 3 times 2, all the way down to 1, okay? So, again, hopefully you've pressed pause and had a go at the example on the right. Now, you can list them out, but it's just quicker if we just use the factorial. So there's 4 cards, so we can just do 4 factorial, and you will see this on your calculator, by the way. That is a symbol on your calculator. And then that just becomes 4 times 3 times 2 times 1. Now, we know that 4 times 3 is 12, and 12 times 2 is 24. So there's 24 possible ways we can rearrange this. And finally, we are going to look at an exam question. So this is to do with a passcode. So we know that the first digit, so it's a 4-digit passcode. The first digit's a cube number between 1 and 9. So we know 1 is a cube number, and so is 8. So there are 2 cube numbers. There's 2 possible numbers that the first digit can be. This is a prime number. Now a prime number is a number that has exactly 2 factors. So it's usually itself and 1. Now 1 isn't 1 because it just has 1 factor. 2 has 2. So there's 3, 4, 5, 6, 7, 8, and then we have 9. So that can have 4 possible options. Any number greater than 6, so that can be 7, 8, 9, so that can be 3. And a number that's odd, so that's 1, 3, 5, 7, 9, so that's going to be 5. So finally, we have 4 digits. So the option for the 4 digits are, we can have 2 possible numbers here, 4 here, 3 here, 5 here. Now if I do 4 times, if I multiply that all out, I get 120. And the question is saying, look at the probability that Amber guesses the passcode, so that would just be 1 out of 120. You can download the full worksheet over at my website for listing strategies. If you did find this useful, I've got loads of other content like this on my channel, and as always, I'll catch you